evaluate the indefinite integral. So our question states that we have the integral of x squared times x cubed plus 5 to the power of 9. So in this scenario, what we want to do is we want to figure out what can we substitute inside the parentheses. Can we take the derivative of that and then get what we have outside of the parentheses? So what we're going to do is take a look at what's here in the parentheses, and we're going to let u equal x cubed plus 5. Okay? And now we're going to take the derivative of both sides. So we're going to have du, which is going to equal the derivative of x cubed is going to be 3x squared dx, and then derivative of 5 is 0. So if you take a look here, outside the parentheses we have x squared times that times dx. So x squared dx is here, but we need to isolate that. So by doing that, we're going to divide both sides by 3. And so we end up getting on the left side 1/3 du, and that's going to equal x squared dx. Okay, so now let's rewrite the question. So we have the integral x squared times x cubed plus 9, plus 5. So let me go ahead and rewrite that. So we have x squared times x cubed plus 5 to the 9th power dx. Okay, so we know that u is going to equal x cubed plus 5 to the 9th power. So that means we're going to have the integral of u to the 9th power times, well, what's x squared dx equal to? Well, x squared dx is equal to 1/3 du. So that's times 1/3 du. So now we're going to factor out the constant 1/3, and then we have the integral of u to the 9th du. And now we're going to take the antiderivative of u to the 9th. So that is u to the 9 plus 1 over 9 plus 1, and that's plus c. So we have 1 over 1/3 times u to the 9 plus 1, which is 10, over 9 plus 1, which is 10, and that's plus c. So we have 1 over, well, 3 times 10 is 30, and that's u to the 10th power plus c. And so now what do we know that we substituted for u in at the beginning of the question? It was x cubed plus 5. So we end up with 1 over 30 times x cubed plus 5 to the 10th power plus c. And therefore that is your result.